type of integration. Oh my god, it's actually writing in the right place.
I still recommend calibrating.
Yeah. Now, I don't even think we got time to finish this, let alone calibrate. So every differentiation rule has its corresponding integration rule. Okay, so every differentiation rule has a corresponding integration rule. So, for example, the chain rule has a substitution rule, right? So chain rule.
Yeah.
Okay, and it's like number 6 back there, right? You can substitute, but sometimes you just do it in your head, right? So you look at x e to the x squared dx, and you just sort of say, well, I could let u equal x squared, and then du is 2x dx, and then, you know, but you can also just kind of do that in your head and just say, hey, get rid of that x squared is going to give me a 2x, I need half of that, and, you know, there you go. So the product rule, let's take a look at the product rule. What does the product rule say? So the product rule says that if I am doing the derivative of the product of two functions, then that derivative is the first function times the derivative of the second function plus the second function times the derivative of the first function. Now, if we were to take antiderivatives of both sides, right? So if we took the antiderivative of this, it would just be f of x times g of x. And this would be the integral of f of x, g prime of x dx. And this would be the integral of g of x, f prime of x dx. And we're going to rearrange this to solve for this expression, right? And it looks like this then, right? We're just going to take this, move it over here, we'll take that, subtract it. So we get f of x, g prime of x dx, sorry, the integral thereof, is equal to, so I move that, it'll become negative, and I move that, the sign, well, actually, let's just move that over. So we get f of x, g of x minus the integral of g of x, f prime of x dx. Okay, and on your formula sheet, it looks like this. So it looks like the integral of fg prime is equal to fg minus the integral of f prime g. And in differential notation, so that's 1, it looks like this. The integral of u dv is equal to uv minus the integral of v du. So both of those forms are sitting at the bottom of your formula sheet, right?
UDV?
UDV
Yeah, more concise.
is equal to uv minus the integral of v du. So, all right, you're going to have that on your piece of paper, right, so we can refer back to this formula. So let's say we want to do...
Dude, it's probably advanced. I can tell from like the...
So here's your question. What's the integral of x cos x dx? So you look at that and you say, can I write that in the form of the integral of a function times the derivative of another function? And so we say, yeah, you could. you could say, well, let's let x equal f of x, and then we'll let cos x be g prime of x, right? Or vice versa. We could do it either way. So the question is, do we make f of x equal to x and g prime of x equal to cos x, or vice versa? So then you say, all right, well, the formula is, so let me just go, we'll write that up here up top. So the formula is the integral of f of x g prime of x is equal to f g minus the integral of g of x f prime of x dx up front there too, right? So we can say, well, okay, if I'm looking at it and saying it's of this form, then I got to say, all right, if I make this f of x, can I find its derivative? Is it easy to find the derivative of x? We'd say, yeah, that's pretty easy, right? If I make, and then is it easy to find the integral of cos x, right? Because we're saying that that's the derivative of something, and we need to find its integral. We're going to need g. You say, yeah, it's pretty easy, right? I could take the integral of cos x pretty easily. Would I do it the other way around? Well, finding the derivative of cos x is easy, but finding the integral of x is going to make it more complicated, right? So here's what we want to do. We want to assign f of x. So we want to assign, like one of these has to become f of x, right? So we want to assign f of x such that its derivative is easy to find. Because we need it, right? We need f prime of x over here. Such that its derivative is easy to find. And assign g prime of x so that its antiderivative isn't hard to find. Usually we're looking at it such that when we find the derivative, we get something simpler, right? And what's the derivative of x? 1. Okay, that's pretty darn simple, right? What's the antiderivative of cos x? Sin x, right? So that's pretty easy, right? That's not hard to find. If we go the other way around, then the antiderivative of x is x squared over 2. That's going to get to be a little bit uglier, right? Okay? Well, won't be wrong. It'll just be a little more work, right? So here's what we're going to do. Scroll this down. So looking at it, so we've got the integral of x cos x dx. So we need to assign, right? So we're going to say f of x is equal to x. So what's f prime of x? 1. And now we're going to say g prime of x, right? So we're assigning f of x, and this is g prime of x. So g prime of x is cos x. So what's g of x? So g of x is equal to sin x. And if we look, what have we got to figure out, right? Okay, so we have f of x, we've got g prime of x, we've got f, we've got g, and we're going to have to do this integral, right, of g of x, f prime of x. So let's write this out. Okay, and all we're doing now is just substituting into the formula. So the formula needs 4 things, right? F, G, F prime, G prime. What do? We assign F and we assign G prime. Okay, so what's this look like? The integral of x cos x dx is equal to, whoops, F times G, right? So x times sine x minus the integral of 1 times sine x dx. Okay, so direct substitution, our f of x is x, our g prime of x is cos x, our f of x is x, our g of x is sine x, and we're taking the integral of f prime of x times g of x. Okay, so this is x sine x. What's the antiderivative of sine x? Minus cos x, right? Because the derivative of cos is minus sine. So this will become plus cos x plus c, right? Some constant that may have been in there or might be there. Okay, and we can do this the same form, right, using the integral of u dv is equal to uv minus the integral of v du. So here we assign u, which would be x, right, in which case du becomes dx, and dv is cos x dx, and so v is sine x. Okay, so this is the order we go in, right? We pick u, we work out du. We pick dv, right, which is the cos x dx. So there's u, there's dv. And so we got u, we got dv, we got the u and the v. So these are going to be written the same. So this really just translates down to that, right? I mean, that's your substitution now. I'm mostly going to use the u's and the v's, okay, when I do that. So if we look here, this is u, this is dv. Come to this is u, this is v, this is u. What's u? This is du, and this is dv. Or that's v. Yeah, sorry, that's v. Okay, which should be v du, but yeah. Okay, let's do a few. So let's say we do the integral. If you do the integral over the interval, that's indefinite. We'll do the integral of ln x dx. So you say, hang on, that does not look like something times something, right? So let's do this. We'll multiply it by 1. That won't change anything, but we're going to say u is ln x, right? Because it's easy to find the derivative of u. Okay, and that makes dv 1, and it's easy to integrate that. Okay, if you make the 1 equal to u, although that's pretty easy to, you can't, it's hard to differentiate, or sorry, it's hard to find the integral of ln x, right? So if you ever see a ln x in here, that's your u. So what's du? What's the derivative of ln x? 1 over x dx, right? Easy to find. So dv is equal to 1 dx. And so v is equal to just x, right?
Why would they use v and u?
It's differential form.
Like, couldn't you use a different letter, like v and u or something?
No, everybody uses u and v. Trust me. When I first learned the product rule, it was like uv prime plus vu prime, and the quotient rule. I learned it in terms of differentials. That's how I learned my formulas. For that, it was all in differential notation. Okay. So what do we got? Well, so the integral is u times v. So ln x times x. That could be a little confusing. You'll think it's like ln x squared. So let's write it as x ln x. Okay. You don't want to write ln x times x. Let's put the ln x in brackets, right? Otherwise, you've got some ambiguous thing, in which case you're still going to be tempted to go ln x squared, which you shouldn't. Okay, so that's uv minus the integral of, and what's the formula say? So it's v du, right? X times 1 over x dx. Okay. So that's x ln x. That's just a 1, right? X times 1 over x. So what's the integral? Integral. Okay. So this expression is just 1. The integral of 1 is x minus x plus c. Okay.
Bingo bango. It's ready to tango.
Bing bang boom.
Yeah. This is my second book I finished. Yeah.
Okay, so again, we look at this. The derivative of t squared is easy to find. And e to the t, it's easy to find, well, e to the t, it's easy to find the derivative or the antiderivative, right? But the antiderivative of t squared is like t cubed over 3. That's a little more complicated expression as opposed to the derivative, which is 2t. So we'll stick with the easy one, right? So when you make your choices, you choose, right? So what's u? T squared du is going to be 2t dt. Okay, what do we choose then? Therefore, dv is equal to e to the t. And what's v equal to? E to the t as well. Okay, sorry, this is e to the t dt. Okay, so the integral of t squared e to the t, okay, is equal to u times v, right? We've already filled this in, so once we've got these 4 guys written down, we're just substituting into the formula, right? So u times v, so t squared e to the t squared e to the t, minus the integral of v e to the t times du, which is 2t dt. Okay, at which point you think, what are we going to do with this? We're going to do integration by parts again, right? So this time we're going to take this one. So let's go over here. I want the integral of e to the t times 2t dt. Right? Well, actually, hang on. Let's do this. Let's get rid of the 2.
Let's use like double.
Let's use M.
M and N. Just even more. It's like
Let's put the t in front. T e to the t dt. All right, so that's what we want to work out here, right? T
Oh, you took a 2 out?
e, yeah, take the 2 out. It's just a constant, right?
Okay.
So we want to work this guy out. Okay. So we're going to say u equals t. Du is equal to 1 dt. We're going to say dv is equal to e to the t dt. So v is e to the t. And the integral of t e to the t is equal to u times v, so t times e to the t, minus the integral of e to the t dt. Okay, right, because the du is just dt. So v du, uv, the integral of v du.
Oh, then do it again.
going like this.
What's the integral of e to the t dt? Just e to the t, right? Plus some constant. Okay, so now we can go back in here and substitute. So we've now worked out the integral of t e to the t dt, which is this. So t e to the t minus e to the t. Let's throw that there. Let's just toss the constant outside, right? I mean, it's just a c. You know, I could put it in there, it'd be plus 2c, and then, but it's just a constant, some arbitrary constant. Okay, we got t squared e to the t minus 2t e to the t minus 2 e to the t
Bless you.
plus c.
No,
Plus, you're right, plus, minus plus 2. Yes. Written down here as a plus 2. And we're done. Okay. 2 more. Well, we're not done. We're done that one. Don't get too excited. So we got 10 minutes. We can do this. We got 1 page. Tomorrow's gonna be basically work period on partial fractions. Okay? Or sorry, integration by parts. Then, what's the day after that? Thursday. Then Thursday is partial fractions. Then you got like 2 work days in a row or something like that.
Thursday we got the grad.
Yeah, but that's last period, and you guys are after lunch tomorrow, so.
Oh.
Wait.
Don't we move as a unit?
game. Okay, so in this case, what's easy to find, right? Well, it's easy to find the derivative of e to the x. So we'll let u equal
Me.
e to the x. What's du equal to? E to the x dx. So we're letting dv equal cos x dx. So what's v? What's the antiderivative? It's just sine x, right? Sine x. Okay, let's write the formula out. Okay, and if you're more comfortable, you can use the f's and the g's, right? F and g prime. So either one, right? You're just gonna write this as fg prime is fg minus integral of gf prime. Okay, either formula is on your formula sheet. Me, I like using these. So the integral of u, so e to the x dv cos x dx is equal to u e to the x times sine x minus the integral of v, which is sine x, times e to the x dx. So let's write that as e to the x sine x dx. Right, a little less ambiguity that way. At which point you're thinking, wow, geez, great solution, right? I mean, you went from the integral of e to the x cos x dx, and now you got to figure out the integral of e to the x sine x dx.
Yeah.
Okay, so the answer is yay. Yeah, let's do that then. So let's go over here and figure out the integral of e to the x sine x dx. And you say, well, you're pretty much repeating exactly what you got over there, right? U is equal to e to the x. Du is equal to e to the x dx. dv is sine x dx. So what's v? Negative cos x, right? Negative cos x. Okay, so the integral, so using the formula, right? Integral of dv of e to the x sine x dx equals, I'm just going to write that on the next line down here. Okay, what do we got? Negative e to the x cos x, so negative e to the x cos x. Okay, I mean it's e to the x times negative cos x, but plus the integral of e to the x cos x dx, right? So v, or sorry, u dv.
Fit it into the line.
No, sorry, v du. V du. And it's minus but negative cos x, right? So that's a negative cos x, we're subtracting, so we change that to adding.
Okay.
All right, great. So what have you done? Well, now you've turned what you were originally trying to find, and you've got it again. But that's okay. It means that if we substitute this for this, what do we get? We get the integral of e to the x cos x dx is equal to e to the x sine x minus negative e to the x cos x plus the integral of e to the x cos x dx. You're going to say, okay, so look, the only integral here is now e to the x cos x dx, right? So we can isolate that on one side. And we're going to do that by going through and expanding this. So e to the x cos x dx is e to the x sine x plus, right, that's changing sign, e to the x cos x minus the integral of e to the x cos x dx. So let's add this to both sides, right? So we'll have two of them. Right? So I'm going to take this, move it over there, it'll become plus. So we've got 2 times the integral of e to the x cos x dx is e to the x sine x plus e to the x cos x. Okay, which means ultimately, what do we get? We get 1/2 e to the x sine x plus cos x. Okay, so although we've done, what the heck is this called? Integration by parts, and we did it twice, and then we said, oh, hey, I've got the same expression, right? I've got another integral of e to the x cos x dx. We can collect them. But we've got 2 of them, so multiply both sides by 1/2, right? Pull out the common factor, and away you go. And what do we need? One more thing. Plus c. Okay, we need a constant. Okay, one more.
Are we doing another question?
Yep.
No. Oh, look. I can do it here.
Okay, so this is formula for definite integral, right? It says if you evaluate an integral from b to a of f of x g prime of x dx, it's equal to the product of the two functions evaluated on that interval minus, and then you're evaluating the integral again from a to b of that other expression. So, integral from 1 to 3 of x cubed ln x dx. Okay, so remember, if you see a ln x, that's your u, because it's easy to find, right? So u is ln x, which makes du 1 over x dx. So then v is x cubed, or sorry, dv is x cubed dx, and v is 1/4 x to the 4th. Okay. And we do that just because it is not easy to find the antiderivative of ln x, right? It's not something anybody knows. You'd have to actually sit down and work it out. So this is equal to, okay, what do we got? F of x, so uv, so 1/4 x, so x to the 4th ln x over 4, evaluated on the interval from 1 to 3, minus the definite integral 1 to 3 of 1/4 x to the 4th, right? So that's v times du times 1 over x dx. Let's just sort of box this off. So let's leave this guy as it is for now. Let's simplify this. Oh, do we need to? We can do that. Let's do the, So that's going to be like an x cubed, right? X to the fourth, x on the bottom is going to be a 1/4 x cubed. So we're going to have to raise the cube to a fourth power and multiply by 1/4. So it's going to give me x to the fourth over 16 on the interval from 1 to 3. Okay, so this is 1/4 x cubed. Raise the power to 4, divide by 4, or multiply by 1/4, you get 1/16. And you got an x to the fourth. Okay, and now we can substitute in. So 3 to the fourth ln 3 over 4 minus 1 to the fourth ln 1 over 4 minus 3 to the fourth over 16 minus 1 to the fourth over 16. Right. Ln of 1 is 0, right? So, gone. So 81 ln 3 over 4 minus, this is 81 minus 1, which is 80 over 16, which is 5. So 81 quarters times ln 3 minus 5.